Yeah, you can start now.
Yeah, that's here is some of the resources or the websites that should be needed. I mean, when you talk about the space science or space exploring. So when it comes to the paperwork or technical researches, I just list a couple of websites. Like, let's say the first one is sciencedirect.com, which is a great resource of scientific researches in a lot of fields, really, not only in aerospace engineering or everything related to the space science or to the whatever else. I mean, disciplines, really. The other one is called ResearchGate. This is another great website. Most of the universities connected to it has a mountain of researching papers, and it's interactive every day or every now and then, bring all the up-to-date researches around all the world. Then is another one. I think that the third one is a Chinese. I'm a member of that one called Ideation. Even this one is very active, really, and they have a lot of resources when it comes to the research points or research paper. Then the astronomy and space science, it's just common. The other one is list of ARL members. And there is a library database. I think that one is referred to the NASA and so on. I just want to concentrate on the last two ones. The ANSYS simulation software. This is something so needed, really, when you work in a space science or you want to work over there. The ANSYS simulation is one of the great softwares that mostly active wherever you go all over the world. I'm working on this kind of simulation software in the CFD side, not so much only in 2 dimensions in the rocket science. I just prepared a couple of papers before concerning the nose cone design of the rocket motors and missiles and so on. But when you get it through the regular website, they'll give you the student version, which is very minimum concerning the main software. The main software could be taken by, let's say, UAE NASA. It's not that expensive for such accomplishment. I mean, but really it's so needed, and a lot of trainings must be done on that software. And they have a lot of training stuff, and they even provide a lot of certificates. I think even the master's degree in a lot of fields, and so on. I mean, and the last one was that is called Original Lab. When it comes to the data presentation, and if you want to see what's going on curves and 2-3 dimension, this kind of software is very, very aggressive, really. I work on that since I think the end of 90s when I was in my country. And I just checked it a couple of days back. It got more advanced and advanced, really. It needs to be taken in consideration too. Are you with me? Am I good with the camera?
Yes, engineer, it's okay.
Oh, okay. Yes.
Yeah.
Okay. And then there are a couple of, infrastructure should be taken in consideration by you guys as a company, or I don't know how you call it, an emirate establishment or kind of company. There should be a large bank of information and data from all over the globe, or global available resources, because as I see here, I remember I was one of those companies here in America. they have a kind of bank of information that's building really, I think 10 or 20 floors. No, not between 10 and 15 now, 10 and 20. When you go inside, it's kind of hardwares, each and every one beside the others. For when you have to go all over, I think the 10 floors. It's a monster bank of information referred to NASA, referred to a lot of a lot of those great companies. And there was a guy really, he was working, he's a friend of mine. So he told me, come on, I want to show you something. When I got inside, I just saw the first level, the first floor. I couldn't go because the security level is so high. But what I saw is something unbelievable. They said all these, you see, kind of like refrigerators, boxes. They said these are kind of hard disks and mainframes and so on. They're holding a lot of data from all over, mostly in America, I think. Some of them are not available to the public or to, unless to the NASA or some high top secret activities. And there should be full long-term programs of training if there should be staff working on in the space science or the UAE, NASA. There should be training programs for the staffs from all over the disciplines, really, from all over specializations, because it is long-term process. You are building a great deal of high-tech fields and technology and so on. So you need to build from scratch, let's say, or from the zero level up to let's say after 10, 20 years or so on, you'll get very good infrastructure, very good solid foundation, preparing people to go to the next step with minimum loss, minimum headache. I mean, propulsion systems are so needed if you want to work on rocket science and you want to go through that side, which is necessarily really what all over the world. If you want to go through space science, you need to have all those infrastructure industries to depend on yourself, because there is a fact that that's saying that no one all over the world will give you whatever they reach. You have to reach the point where you have to dig yourself to get the best out of whatever available. And let's say propulsion, aeroelasticity, electronic systems, fueling system, I know that stuff, launching systems, all these stuffs go back to the, if you go and check the NASA websites or YouTubes, you'll see how those guys are working on every single field of that. It needs a very great management, engineering, or whatever kind of, a lot of management, really, especially engineering management, to go through all these resources. Because really, I worked in such field in my country since 19, let's say 84 up to the point where I came to USA. It is not easy job, really. You will face a lot of problems and a lot of headache, and you have to be ready to deal with that. Learning, asking, tracing papers, tracing seminars, tracing conferences will be so needed to be at the top. I mean, at least you are not far away from the others. And that's what all the countries all over the world do. I mean, if you just check, even the Arab countries, let's say in Egypt, they have a very old program in this field since I think the 60s or so, and they're working so hard, and they have a lot of qualified people, really. such a place, I mean, such a research facilities in Egypt should be taking consideration, making kind of connections with visitation, consultation, and so on. Then these are kind of softwares used to dealing with the data. I mean, what as I told you, this is the first one is the Origin Lab. This guy is very sophisticated, really. You can take for example, when we work on the rocket science, you can take the data from the wind tunnels or from simulations, drop them in those something like spreadsheets, really. And then you can ask the software to give you all these information in the equation form, and you can put your equation and write it down, and the software take that equation, give you the results, and give you the percentage of the results compared to the mathematical model you put. Let's say this kind of model work on such data 90%, 80%, then you know how far you are from the I mean the correct line. And you can fix that. There is a lot of means and techniques and numerical methods in engineering application, which is field I worked in since more than 20 years. How can you manipulate and play with those data and try to minimize the error between the theoretical model and the actual data came from whatever sources. ANSYS, as I told you, this ANSYS is very huge. Those guys are working so hard. So let's say in the space science, you will need this software. Actually, you'll need it because it has a lot of fields and a lot of networks, and but it needs a lot of training. I am working on that. I couldn't find a way to get good deep course, but I'm working, trying to learn myself, and I worked on that software up to a point where I could get information, draw model, and run it on let's say subsonic, supersonic speeds, and see the results. And then if we can find or have a chance to compare them with wind tunnel and lab results and see where are we at from that one. Should we correct the model? Should we do this and that and so on? Excel I'm working, even Excel is this software is no one, I don't know, I haven't seen a lot of people know about this. I'm working on Microsoft Excel spreadsheet since it was called Fox 3 or Fox Pro around 1991, 92, and then came out as Excel 3, and then Excel 4, and then Excel 5, and then Excel 17 and 97, and go on. But this kind of software is very powerful. You could program it. It's not only spreadsheet where you put data and draw curve, whatever. No, there is coding, and there's non-coding programming. I work on this sheet up to this point before I joined you guys. I'm working on paper, doing some kind of design and simulation, nose cone missiles and supersonic and hypersonic speeds. Then there's another software called Ocadel Engineering. This website, I think it's from Germany. I remember I saw that one since I was doing my master's degree in 1999, 98. These guys are working actually on the nonlinear models. They have a lot of mathematical models that working on the nonlinear data models and try to solve them and give you a lot of form of mathematical models, which you have to choose. You have to work on that really, and you have to have that kind of engineering mathematical background to know which equation should be taken to which kind of data curves. And then from that, you can get whatever you want out of that mathematical model. The last one is Science Director's website. Really, this one is very strong and is a mountain or ocean of research papers in different fields. Well, let's say when it comes to engineering and my field, I find a lot of, but most of them, the sophisticated ones, you have to pay for that. So you need to have subscription. I mean, as an UAE NASA, you have to. I think I advise that you should get annually subscription of these mostly all these sites, because these are the weapons and the armament needed for whatever scientific establishment all over the world. And wind tunnels. I don't know, guys, did you start building or buying or dealing with wind tunnels or not in UAE NASA? If you check, if you go to America and see those guys in NASA, they have what is called real model NASA wind tunnel. Wind tunnel is a place where they test their models. They test the model of rocket, model of car, model of whatever, bike, whatever you want. And you see here in this picture, this is a real scale F-18. They are trying to test it at a very high angle of attack, and the flow comes from all these big structure through a lot of fans and blowers and compressors. And then what this airplane stand still on, they are called load cells, or load cells, where they get the data of pressure and moment and drag and so on. So this is one of the models, this is another model. It's 1-to-1. It's kind of, I think this kind of airplane, or yeah, because it has kind of two turbofan engines, or but they just put it this way and they start blowing the air at certain speeds with well-known density, temperature, and so on, and pressure, and see how it affects this kind of mathematical model. And here another one. This is these are the boosters of space, not rockets. Like, I mean, I remember Challenger, Columbia, and those space shuttles use these kind of boosters to push them out of the space. So before they put them on that space shuttle, you see where they test them. I think this is not scale 1-to-1. Maybe it's kind of 20-30% of that, as much as I could guess from the forum. And blowing the flow on such models will give them all the information needed about the fluctuation, where the flow separated, is the thickness good enough to resist the whole dynamic pressure through the flight bed, and so on. And here is another test. If you see, this is the space shuttle parachute. When it lands down touch the ground, they came out like the supersonic aircrafts. But this is kind of a huge parachute. You see how big it is compared to the people down. And all this structure is the wind tunnel, where the flow should come at very high speeds, straight to, and then they measure the strength of these cables holding this parachute, and the structure of the parachute, if it is good enough, or it needs kind of correction and change in design and so on. These are some of the, and here's, if you see, this is all this structure. This is the building of the wind tunnel, where at some point of these tubes you find test sections inside, but this is, I think, scale 1-to-1. or scale a little bit less than that. I remember for such when as I went to trip to China, it was kind of we were trying to test kind of models of rocket models on very high hypersonic speed. I remember I saw that that test when the speed compared to the speed of sound was the Mach number was 12. It was very aggressive, and the model of the rocket turned to be so red out of the high temperature, and it was almost be melted. But they said they have a very big, really wind tunnel. When you see, if you see those balls size, these are the compressors. You see them a lot of. I saw in China. I saw, I think, 20 of very big compressors. They said they keep almost 1 or 2 days to fill them up, and then to release that pressure out of them, and the flow comes through all these pipes until it reach the what is called the test section, where a model of the rocket nose cone or the whole rocket or whatever the test at that point, and they get the full a lot of reading data through the computers and so on. So I mean that's mainly, I mean, some of the needs to establish such a great project in Emirates or wherever. Emirates, I'm quite sure people, you guys over there, you have all the capacity and capability to go ahead and far away in such field, because such kind of business needs a lot of budget power, a lot of strategic point of views, which is, I think, available in Emirates. As I see, at least you have the great foundation and you have the intention to go all the way. That's mostly, I think, all what I can say about this point up to this news. So I don't know if you have any questions or or any other point of view. We can cover it next time. That goes to you guys. And
Thank you, Engineer Asad, for that great explanation and that great experience you had in the space field.
that's my job, really. Since I graduated from university, I stuck in my field. I didn't go here or there. So I'm doing aerospace engineering since my childhood.
And we are so proud to get some of this experience in this presentation, and as you are our mentor in NASA Space Academy. I think I had a question from my side. What do you, how do you see the development in this industry of space industry and discovering the space? How do you see the next steps in this industry?
The next step should be you firstly you should start from where the other end. We don't have to start from scratch. Let's say from 1950s, where everything was so retarded. Now the capabilities and the capacities are so high. Let's say, for example, you need to have mainframes of supercomputers and the up-to-date, high-tech equipments needed for all the fields. Some of the fields really I have no idea about. I'm not good at electronics or let's say or other fields, but you need to be, I mean, consultation and getting ideas and getting through the conferences, and need to hire the high tech experienced people to take you from the ending point and go up. Like you have to do it like what the Japanese did. they didn't start from the zero. They start from where American and Russian stopped, and now they are really masters. They have a very, very great advancement in such field. Let's say some of the American rockets, uh, and I think even the space shuttles or not, they use the Mitsubishi rocket motors on their systems. Mitsubishi company is very great in such a field, and even Russia, they depend on the Japanese when it comes to the rocket. When the rocket comes to the rocket motor industry, because they just took that part and start working so hard on only on the engine section. And nowadays, really, they are at the top. You know, if you could count the countries, let's say the 10 countries all over the world, they are one of them. Let's say America, Russia are the pioneers actually in such a field. Then it comes France, UK, Germany, and even South Korea. Those guys they start from nothing really, and they got all the experience from other countries, and nowadays they are masters. They have even the upper hand in a lot of fields. So this is kind of as much as I've learned, and I had experience when I was in Libya. We were working. We had a lot of headache and obstacles. We stuck at some of them, and we tried to resolve some of the others, but we reach sometimes a point where you don't know if you are going right or wrong. You need some kind of experience reference that you can ask, and you need someone to guide you. They tried once, I remember, to get cooperation with the Ukrainian people. The Ukrainians they have very advanced industry when it comes to the rocket science and space science. Most of the Russian rocketry system, if you ask about Russia, it is Ukrainian. Ukrainian people, they have a very sophisticated stuff. Maybe I could say at this point of time, with all those catastrophes, one can go and check. You can get at least references and whatever need to start building your infrastructure of the UAE and NASA. Yes.
Okay. If you had any question for the attendees, please type it in the Q&A section, or you can type it direct in the chat box.
Mm-hmm.
And also, Engineer Asad, this session is recorded and it will be published with the participant today. So if we get any question for you or someone need to contact you, we will be pleasure.
Absolutely. Absolutely. I will even share, I have some papers, really. I have too much papers, and I'm working on these days on designing of nose cones for the rocket models or missile models in high supersonic and hypersonic speeds. It is kind of really headache. I'm working a couple of years on one paper already. I didn't finish it yet. And I'm trying to compare my results to other papers and other resources. And sometimes I found myself far away and found some mistakes on how I did that. I have to correct that. It's kind of really hard and headache study and kind of job. But I'm on that. I mean, I will reach something. I'm quite sure at the end of the day, and then I publish papers. I'm not. I published a couple of papers, not that much really, but go through papers, it's kind of big headache. It's not easy job to write paper. I think it's easier to write textbooks, very far better than writing paper. But anyways, I am ready to any questions. If anyone has any exclamation or something in my field that I have answered to that, I will be grateful to give whatever I want.
Thank you so much, Engineer Asad, for that great help. And if you want to add anything for the participants or advice, we had still 2 minutes for this advice.
Okay, for now it's okay. I think I have some kind of here. There is some anonymous. How can we come up with a good idea? Oh, how can we come up with a good idea? It really needs to. You have to. We have to study and compare and see. Firstly, you have to have a goal. What is your goal? Should I write it down, or this gentleman or lady or gentleman listening to me? That's
It's he or she one of our participants, and you can answer her. She will or he
There
will.
should be there. There
Yeah.
is a button called answer live. Should I?
If you
Click
answer,
yeah.
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 Oh, okay. As I said, would you like to answer? Yeah. I don't know how about it. Okay. Anyways, as I said, to come up with good idea, you have first to decide what is your goal, what is your target. Let's say my target is to design a space shuttle that goes to Mars or whatever, and it needs this and that. What is the weight? What is the fuel? What is the shape? And is it empty or to carry kind of satellite? Then from that point, I have to separate all those files and start working on it. Let's say working on the air elasticity or the structure of the rocket or the missile. Then what kind of engine, what is the thrust, what is this and that, and you have to put all those parameters to know if I want to design, let's say the nozzle. I need to know the nozzle, what is the thrust it will give me, is it enough, or should I make corrections and so on. And at that point, that all those obstacles will come up and up and up, and you have to solve. You have to solve, and you have to deal with them. It's really a group job. It's not my job. I can't do all that. No one could do it. It needs kind of let's say a company like UAE, NASA. Should be divided in groups and departments, and you should hire very high smart guys and hard working guys too. It's not only smart, really. It needs someone to be ready to be a hard worker, because the problems are not that easy. It's kind of zigzag foxy way. You have to, whenever you think, there is a wisdom saying that whenever you think you are okay when it comes to the rocket science, you gotta be careful. There is a trouble waiting for you somewhere. And I saw that in my eyes. I remember we tried to test one of the rocket motors in my country a long time ago, and we just put it on the test stand and measured the pressure and the temperature and everything. And as soon as we start that ignition, that engine just exploded, and we were our life were on the line, really. And we discovered that the flow was not stable, and there's something here, and we have to calibrate this valve and be careful to that pipeline and this. I mean, all that stuff will pop out. If you remember the Challenger, when the Challenger exploded, they discovered that one of the O-rings of one of those boosters, it should be changed But that guy, one of the guys said, no, it's okay. I see it very good. It's still new, and you just keep it. And then when they run that motor to the sky, a couple of seconds, and then you know what is the catastrophe happened. Anyways, I mean, to get a good idea, you have to define what you want to, and then consultation and preparing steps, and then start working, because working will never go. The thing I'm guarantee, working in this field as in any other field will never go smooth. You have to try and do this, and then you find yourself made a mistake and you have to correct. But you know, guys, you have to be patient and aggressively hard worker to go where the other gone. I mean, there should be a good result at the end of the day. That's you have to be trust. You have to yeah. I mean, you have to trust that everything will be okay. But we need to have a very aggressive work as well. That's for done. Should I do done this way? I don't know if.
I think that is the question we had, and thank you again, Engineer Asad, and we
Yes.
hope to see you again, inshallah, in our mentorship sessions or
Yeah, I am. Yeah, I'm
programs.
all the way. Just we'll keep in contact, and whatever else pop up, and I'll be ready just to contribute as much as I can with my little experience in such field.
Thank you so much. Thank you.
I really appreciate it.